Before we start answering these questions, it's worth taking a look at our equation. V squared minus u squared equals 2as. It's worth noting that this equation can be rewritten by adding plus u squared on both sides, which gives you v squared equals u squared plus 2as. It's also worth remembering that this equation is essentially v squared equals u squared plus 2 times a times s, where v equals final velocity, u is equal to initial velocity, a is acceleration, and s is distance. Now let's take a look at our first question. So, as with any question, let's read it and find out the necessary information, or the useful information rather. So question number 1. A car begins at a speed of 3 meters per second. So again, right from the beginning, begins at a speed of 3 meters per second. That suggests that this could be u. And accelerates at 2 meters per second squared. That's a, over a distance of 40 meters per second. That's s. Calculate the final speed of the car. So let's find out and write down what we know. V is unknown. It wants us to calculate the final speed. So let's leave that for now. U, the car begins at a speed of 3 meters per second, so our u is 3 meters per second. Acceleration is 2 meters per second squared. And distance, s, is 40 meters. So before we begin substituting our values, let's write the equation. V squared equals u squared plus 2as. That's 2 times acceleration times distance. After that, let's substitute our values into that equation. V squared is still v is still unknown, so we'll leave that as it is. U is 3 meters per second, so that becomes 3 squared, plus 2 times acceleration, which is 2, times distance, which is 40. So v squared equals 9 plus 2 times 2 times 40, which is 160. Remember, you can use your calculator for this. Equals 169. So v squared equals 169. You can square root both sides of the equation to solve for v. This gives us v equals 13. Remembering our units, we're talking about velocity here, so it's 13 meters per second. And that's our